Hello, this is Mrs. Snook with Section 2.3, Real Roots of Polynomial Functions. Our objectives today are to use long division to divide polynomials by other polynomials. We can also do the same thing with synthetic division, and we're going to also use the remainder theorem. That's a nice way to use synthetic division to evaluate a function. And lastly, we're going to use the leading coefficient test to help us locate zeros of a polynomial function. So here goes. First, we're going to do long division. We're going to use the same algorithm that you used back in elementary school. So I'm going to write 6x cubed minus 19x squared plus 16x minus 4, and I'm dividing that by x minus 2. All right, just like elementary school, how many times does x go into 6x cubed? The answer is 6x squared, and I'm stacking it on top of my x squared. Now I multiply, just like in elementary school. 6x cubed minus 12x squared. Now in elementary school, you would subtract. To do that with polynomials, change your signs first. So that's a negative, that's a positive. I circle my signs so that I know that I've changed them. Otherwise, it's easy for me to forget. Those cancel out. I have a negative 7x squared. Bring down your 16x. All right, then repeat. How many times does x go into negative 7x squared? And the answer is negative 7x. Multiply. Negative 7x squared plus 14x. Change your signs so that you can subtract. Those cancel out. 2x. Bring down negative 4. How many times does x go into 2x? It goes in twice. So plus 2. 2x minus 4. Change your signs. Remainder 0. All right, so we know that x minus 2 is a factor. The next thing I'm going to do, since it asked us to factor completely, is I'm going to take this remaining quadratic, this one right here. I'm going to take that and I'm going to factor it. So I have 6x squared minus 7x plus 2. My preferred method is slip and slide. Use whichever method you prefer. So I take my 6, I slip it, x squared minus 7x plus 12, factor that, x minus 3, x minus 4. Now we got to undo that slip, so I'm going to slide a 6, simplify, x minus 1/2, x minus 2/3, bottoms up, so 2x minus 1 times 3x minus 2. So here's my factors. Factored completely, this is x minus 2 times 2x minus 1 times 3x minus 2. And we're done. All right, next one, we're going to do another long division. The difference here is we're missing an x squared term and an x term. So we're going to have to fill those in when we go to divide. And what I'm going to do is I'm just going to put in some zeros for them. So 8x cubed plus 0x squared plus 0x minus 1. I want to give myself some room here. By 2x minus 1. All right, just like before, we are going to use the algorithm from elementary school. So at this point, I would like you to pause the video, try dividing this on your own, and then compare and see how you did. So please pause your video now. All right, so I got 4x squared plus 2x plus 1. Did you get that? If you did, congratulations. If not, pause the video, compare your work to mine, and see if you can find your mistake. All right, next one we're going to do. Again, we're doing long division, but notice this time we've written this one in reverse order. So I need to rewrite this starting with the highest exponent and working my way down. Also notice I have a trinomial over here. I can still use my same algorithm even though I've got a trinomial there. It's just fine. So let's rewrite 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 and x squared plus 2x minus 3. All right, so just like we did before, I'm going to start with x squared, and I'm going to see how many times x squared goes into 2x to the fourth. And it goes in 2x squared times. Multiply 2x to the fourth plus 4x cubed minus 6x squared. Change your signs. This is going to be a minus. That's a plus. Cancels out. Also cancels out. That's nice. And I get x squared. Bring down my 3x. How many times does x go into x squared? Well, it goes one time. So x squared plus 2x minus 3. Oh, and since I went over here, let's go ahead and bring down the minus 2 as well. And I'm doing that because I had to put my 1 on top of the negative 2. All right, so change your signs. That becomes a minus, that becomes a minus, that becomes a plus. That cancels out, and I get an x plus 1. Now look at there. That's a remainder. So when I write my answer, I'm going to do like we did back in elementary school when you had a remainder. You put that remainder over what you were dividing by. So here's my answer for the division. Oh, sorry, it jumped on me. 2x squared plus 1 plus, here's my remainder, x plus 1 over x squared plus 2x minus 3. And that's the answer to that one. All right, let's move on to synthetic division. We've done a lot of long division. Synthetic division is super nice. It's a very easy way to divide. Its only limitation is you have to divide by something in that form, an x plus or minus and then a constant. So you can't throw in a polynomial like we did in this last one. But here's how we do this, and it's really nice. I can't emphasize how nice it is. We're going to take the coefficients of each of our terms. Notice we're missing an x cubed term. So I'm going to add like a plus a 0x cubed in there. So I'm really going to do synthetic division on this. X to the fourth plus 0x cubed minus 10x squared minus 2x plus 4. So I set this up by first getting the coefficients of my polynomial. So I have a 1, that's invisible coefficient in front of x to the fourth, 0, negative 10, negative 2, 4. And then I'm going to draw in a bracket like this. The other thing I need to do is I need to change the sign on my x plus 3. So instead of using a plus 3, I'm going to use a negative 3. Just like that. I don't need the x, I'm just going to use the negative 3. Now I'm going to start my synthetic division. Bring your first number down. Now I'm going to multiply. So 1 times negative 3 is negative 3. I put my answer in there. Now I add. 0 plus negative 3 is negative 3. Repeat, multiply. Negative 3 times negative 3 is a 9. Add. Negative 1. Multiply. Negative 1. Negative 1 times negative 3 is a 3. Add that, I get a positive 1. 1 times negative 3 is negative 3, and then add that, and I get a 1. That 1 is a remainder. If x plus 3 had been a factor and divided evenly through, my remainder would have been 0. So here's my answer. Now what happens when you do your synthetic division is this column up here used to be the x to the 4th, this one's x cubed, x squared, x, and your constant. But everything has shifted down by one exponent. So this column here is now x cubed, this one's an x squared, that's x, this is constant. And there's your remainder. So my answer is x cubed minus 3x squared minus x plus 1. And just like before, put your remainder in the numerator, and what you're dividing by goes in the denominator. Now we're going to use the remainder theorem to evaluate a function. What's nice about this is all you got to do is synthetic division again, and the remainder that you get out is what this function would be evaluated at. So since I'm evaluating at x equals -2, set this up just like before. There's going to be one small change, and I'll mention that in a minute. So I have a 3 for the x cubed column, an 8 for x squared, a 5 for the x, and my constant is -7. Now this time, because we're evaluating, I'm not going to change the sign, so no change. So I'm just going to use -2. That's the only difference. No change when you're doing the remainder theorem. Bring this down, 3, and then just like before, 3 times -2 is a -6. Add that, you get a 2. 2 times -2 is -4. Add that, you get a 1. 1 times -2 is -2. Add that, you get a -9. That's your remainder. So f of -2 equals -9. Done. You don't have to do a whole lot of work, a whole lot of plugging in for that. All right, now we're going to factor a polynomial. We're going to use repeated division because we're going to show that x minus 2 and x plus 3 are factors. So I have to do a synthetic division for each one of these. So set it up just like before. 2, 7, -4, -27, -18. I'm not missing any of my terms, so I don't need to put any zeros in. Put in my bracket. I'm going to divide by x minus 2 first, so change that sign because I'm dividing. I'm not evaluating, I'm dividing, so change from -2 to +2. Bring down 2. 2 times 2 is 4. Add, I get 11. Multiply, I get 22. Add, I get 18. Multiply, I get 36. Add, I have 9. Multiply, I have 18. Add, I get 0. So I know x minus 2 is a factor. It factored out perfectly because I have a 0 as a remainder right there. Do the same thing, but this time I'm doing it with -3. I've already proven that x minus 2 is a factor. Now I'm going to repeat myself. I have x plus 3 as a factor. Change that +3 to a -3. Bring this down. 2. 2 times -3 is -6. Add that, I get 5. 5 times -3 is -15. Add that, I get a +3. 3 times -3 is -9. Add that, I get 0. All right, that means that's a factor as well. So here are my factors. I have x minus 2. I have x plus 3. And since I did synthetic division twice, my exponents get reduced by 2. So I had x to the 4th up here. Down here is going to be x squared. So I have 2x squared plus 5x plus 3. If I wanted to, I could continue and I could factor it all the way. In fact, let's go ahead and do that. Let's factor this all the way. I'm going to slip and slide on this. So 2x squared plus 5x plus 3, flip the 2, x squared plus 5x plus 6. factor that, x plus 2 times x plus 3. And then I'm going to, since I slipped a 2, I got to slide a 2, divide by 2, and I get x plus 1. This one, it doesn't reduce, it's just a fraction here, so I'm going to bottoms up on the 2, so I get 2x plus 3. All right, so here are all of my factors. X minus 2, x plus 3, x plus 1, and 2x plus 3. Those are all of our factors. All right, the fourth idea we have is the leading coefficient test. And what it does is it lets you write a list of possible zeros. And then you can use that list to start plugging in and see if you can find some zeros that way. So it's a way to help you with guess and check. You know, if you're trying to guess and check your way through this, you don't want to use every single possible number that you can think of. What we want to do is just generate a list to start with. So what you do is you take the leading coefficient. In this case, our leading coefficient is an invisible 1. That's a 1. You also take your constant, your last term. That's also 1. And you're going to write all the possible factors of your constant term. Now my possible factors of 1 are just 1 and negative 1. So I can do 1 times 1. I can do negative 1 times negative 1. And you're going to write all the possible factors of your leading coefficient. That's also 1. Let's just use 1. And then you're going to put all your possible constant terms, all those factors, over all your leading coefficient factors. So what I end up with is my rational zeros is going to equal all my possible constant terms, which is 1. All my possible factors of negative, which is also 1. And this is a plus and minus. I should have put that in there earlier, because you can do a negative 1 times negative 1 and get a 1. And same thing with positive 1 times positive 1. So when you do that, you end up with your possible rational zeros as plus or minus 1. So you go in there and you're like, all right, I can have a plus or minus 1, and I can go ahead and I can test these possible zeros. So I can plug in a possible 1 here. So f of x equals x cubed plus x plus 1. And let's see what happens when you put in 1 as your 0. So f of 1, x cubed, which is 1. So 1 cubed minus 1 plus 1. I get a 1 cubed, which just equals 1. That doesn't work. Let's do f of negative 1. Negative 1 cubed minus 1 plus 1 is a negative 1. That also doesn't work. So this one doesn't have any rational zeros. If you were to do a graph of this, you would find that it doesn't cross the x-axis. Except, so if you graph this function, you might think that it's not going to cross the x-axis, but take a look at the graph that I did on my calculator right there. We do have one crossing. So what this means is that these are not rational zeros. We can still get an irrational zero. All right, let's look at another one. We're going to use the rational zero test to find the rational zeros of 2x cubed plus 3x squared plus 8x minus 3. So we're going to get the factors of our constant. That's 3. So your factors of 3 are plus and minus 3 and plus and minus 1. We also need to get the factors of our coefficient, which is 2, plus and minus 2, plus and minus 1. So remember, put the factors of your constant over the factors of your leading coefficient. I just went ahead and put in a fraction bar. And that means my possible rational zeros are going to be plus and minus 1, plus and minus 3, plus and minus 1/2, and plus and minus 3/2. So that gives me a list of 8 possible rational zeros. All right, so what we need to do is just start plugging in. I'm going to start with 1. I'm just going to plug in 1, and I'm going to do that with synthetic division. So here we go. Plugging in a 1, so I don't change my sign because I'm evaluating. And I have 2, 3, 8, and 2, 3, sorry, that's a negative 8, and that's a positive 3. Bring down the 2. I get a 5. Add, negative 3. All right, we lucked out. That worked. So 1 is one of our rational zeros. So since we've got it down to a quadratic now, let's check this out. I now have 2x squared plus 5x minus 3. I can go ahead and instead of keeping on and plugging in more rational zeros, I can go ahead and factor that. So let's slip and slide on this one. 2x squared plus 5x minus 3. Slip the 2, x squared plus 5x minus 6. We're going to factor this. I need 2 numbers that multiply to 6, but they're going to add to a positive 5. One's positive and one's negative. Check it out. 6 and 1. Now I've got to undo my slip. So I'm going to slide a 2. I get x plus 3 and 2x minus 1. All right, so here are all of my factors. X minus 1. No, let's not do that. Instead, let's find the rest of the zeros. So just like we did in the last section, you can set these factors equal to 0. X plus 3 equals 0, so x equals negative 3. And then 2x minus 1 equals 0. 2x equals 1, x equals 1/2. So here's our zeros. We got 1, we got a negative 3, and a positive 1/2. Notice all of those were on our list. So just want you to notice that this is a way that you can generate a list of rational zeros. Probably the best thing to do is like I did here. Once you get 1 and you can get yourself down to a quadratic, go ahead and factor that and see how that goes. All right, that's it for today's lesson. Thank you for watching and have a great day.